I guess me, I got it correct. But yeah, everyone did get it correct. This is a prime example why you want to do that check first. Is your little dangly arm longer than the fixed arm? That's what that guy does. It's just your hand. It dangles there. Is your dangly arm longer than your big arm? If it is bigger, you're done. It's one oblique triangle. You don't have to find the height. The only way this problem turns into a long problem is if you didn't do that check, and then you have to find your height, and then you have to compare it, and then you have to check this at the very end that it's not. So just do that check first, then you don't have to worry about it, and hopefully it turns this problem into a super easy, quick one, and you're done, and you're on the next problem. All right, any questions about this? All right, any questions from the homework?
Number 25.
Pablo, thanks for raising your hand.
Okay, 21.
Okay, 21. That is the hardest of all of the problems. So let's go over 21. So here's the problem with 21. There's no good place to put our height that we can solve it. So I just went ahead and I put my height traveling down B, because then I would have my base. My base would be 12.6. And maybe I'll highlight that. My base would be B equals 12.6. And the hypotenuse that I would need to find the height would be 13.7. So in fact, I could go ahead and find my height right now if I knew this angle. So I have my base. That's good for half a base times height. I have my hypotenuse to find my height, but I do not have the angle. I need this angle because the sine of this angle would be opposite, which would be h, over hypotenuse would be a. So I need to find angle C. The problem with finding angle C is I also don't know side C. So if I was trying to use the law of sines, and I would say something like A over sine A equals C over sine C, I don't know the angle C, nor do I know the side, so I can't actually use that one. So to kind of work around that situation, I went ahead and found angle B first. Because if I know angle B, I know angle C because it's just 180 minus those other two angles. So to find angle B, I went ahead and used the law of sines. I said the sine of 39.4 over 13.7. So sine of A over side A is going to equal sine of B over side B, which is sine of B because I don't know B, over 12.6. Simplifying down, I get sine of B equals all this stuff. I have to take the inverse of both sides to get B equals 35.7, which then gives me C equals 104.9. And once I have C, I just use C to get my height. Once again, sine of C equals opposite, which is h, over hypotenuse, which is 13.7. And that simplifies down to h equals sine of 104.9 degrees times 13.7, which is 13.2. Plug it in our area formula, and you come up with 83.1 units squared if we had units. Does that suffice? Does that make sense? And we're going to learn today that we need side, angle, side to actually find the area of these triangles. We need side, angle, side. So if we look here, we have a side, we don't know this angle, and I have this side. That's why we had to find this one. We can also have side, 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 and we'll learn about that today as well. All right, Logan.
How do you know to do a BC like that? Where to put the angles?
You don't.
So
you could have did A, B, C. You could have did B, C, A.
Okay.
There's no set order. I just do this almost every single time. I usually put A in the bottom left, and I either put B on top or I put it there.
Okay.
It doesn't matter where you put it because your height. So if my B was down here, my height just would have went through the angle B here instead of straight down.
Okay.
I put it this way because I knew what I was going to look for, honestly. But you don't have to know that. Just label it A, B, C, however you want to. Okay? Because those are arbitrary. Other questions? Yeah, Will.
So this isn't like a question about a specific problem, but
Well, then I don't care.
oh,
No, I'm just kidding.
so
Yeah.
like when you're finding the area, it doesn't really matter what side you use as your base, right?
Correct. Yep. And that's why I specifically picked the one yesterday that went the wrong way. I think that's the one that went sideways on me that day that came out with errors. Yeah. Yeah. So 25 isn't that bad of a problem as long as you picked the right height and drew it. So I drew my height right here. I drew it through B, and I picked B primarily because I can easily find angle C, because I was given these two angles, so I found this one, and I had the hypotenuse for it. So if I drew my height through B, I had the angle, 82.5, and I had the hypotenuse. So I could go ahead and find the height right off the bat. In fact, I could jump to this step way on the right already with all the information that was provided for me and find my height. So I could have did that right off the bat. Now the only thing I need to find is the base then. If I use this as my height, B is my base, and I just went ahead and used the law of sines to find B.
Okay.
So the big thing is, it's going to be easier after today, but on this one you want to find a height that has an angle across from it and a hypotenuse and a base. You need three things: an angle, a hypotenuse, and a base. I'm looking for, can I get two of the three? Because then it's easier to find the third one. If I would have started with angle A here, if I would have picked A as mine, I'd be missing the base and the hypotenuse. I'd have to find two things.
And we just use law of sines to get the bases.
Yeah, yep.
Okay.
Good?
Yeah.
Cool. Other questions? Yeah.
You do 19 over.
Yeah. So 19, once again I did my A, B, and C. It said that side A was 12.9. It said that side B was 6.4. And this is 13.7. This is awesome because it's side angle side. So I had my base. I had the angle to find H, and I also had the hypotenuse to find H. So it really was just finding H. And that was it, because then I already had my base. It was only finding the height. And you can easily do it because it gave you all the information needed. Nothing was missing. Are other questions? This is the ideal one. Notice it's side, angle, side. It is the most ideal situation.
It's okay that I got 9.9 because instead of saying H equals 3, I got 3.1. So that won't be anything off, right?
It was 9.6 off?
Wait, what? No, wait, what?
What did you say you
No,
had?
I got H equals 3.1 and then I just got 9.9. Like that wouldn't be anything off, right?
9.9.
Was my final answer.
Because I think you accidentally wrote 12.6 instead of 12.9 in the equations.
Oh, yeah. Oh. Oh.
Do I get a point for that?
Lizzie gets a point. She pointed it out.
What?
She pointed out the mistake. Yeah, no. Yeah, on these, some of them are going to be close. And especially because I didn't actually write 3 in my calculator either. I actually plugged in this whole thing into my calculator. Yeah, no, you're fine. So Lizzie gets a point. Other questions? Almost. No, Lizzie noticed the mistake. She even pointed out where it was. Okay, let's go into today's lesson. Today's lesson is the law of cosines. All the way throughout, we've been hopefully labeling our triangles. I've been doing it on my answer key. Whether it was angle, angle, side, angle, side, side, whatever information was given, we should be labeling our triangles that way, is because today we're going to learn the law of cosines. And those are going to be the ones where if the given information is side, angle, side, or side, and I need to find missing information. So this is where we definitely want to do that check on every triangle we do, because on the test, there isn't going to be a law of sine section and a law of cosine sections. I'm just going to give you a triangle, and I'm going to tell you to find the missing parts. You have to be apt enough to go, okay, this is side, angle, side, I have to use the law of cosines for this one. Or it's angle, side, angle, I have to use the law of sines to find this missing material. I'm also going to note once more, you have an identity sheet that you're allowed to write. Basically any formulas you want to, and these are all formulas. If you want to write them down, you don't have to do it now because we are going to move on, but I would do that if I was you. All right, our first problem is solve for side x. Now remember, we can either use the law of sines or the law of cosines, and it's all dependent on what information they gave me. They gave me a side, two sides, and an angle sandwiched in between them. So that's going to be side, ooh, that's a highlighter. That's going to be side, angle, side. And since it's side, angle, side, we have to use the law of sines, or cosines. And in fact, we're going to use the one that's to the left. Since it's side, angle, side, we're going to use the one that's on the left, which is that a squared equals b squared plus c squared minus 2bc times cosine of a. So filling in that information, we're going to come up with x squared equals the two sides I know squared, so that's 3 squared, that should be a squared, plus 5 squared. And that's minus 2 times those same sides, 2 times 3 times 5, and finally times the cosine of the angle opposite the side I'm looking for, so that's going to be 39 degrees. And yes, we would definitely need to pull out a calculator. Yes?
Does it matter which one you use, like, out of the 3 formulas?
No, they're all the same thing, because A and B and C are kind of arbitrary. All these are really saying is a squared equals the other side squared plus that third side squared minus 2 times the 2 other squareds times the cosine of the angle opposite A. That's all they're saying. These are all the exact same formula. So we have x squared equals that. I simplified it just a little bit because you can actually plug a whole bunch of stuff in your calculator. So I had x squared equals, I did some simplifying on this side. I had x squared equals 34 minus 30 times cosine of 39 degrees. And you would need to take the square root of both sides, and you should come up with x is about a positive 3.3, because although square rooting makes a positive and a negative, we're talking distance, so we're going to have 3.3. We're not on the unit circle right now. It's just a regular triangle. So double check to make sure when you plug this in a calculator you get 3.3. So on Friday, we had a really good idea to bring your calculator, because we're going to be putting long equations into a calculator. It makes it a lot easier to have your graphing versus trying to use one of my scientific ones. Is 3.3 correct? Really? Yeah, it's 3.3. Yeah. I just round to the nearest tenth. A good advice to you in life is if they don't tell you where to round to, a tenth is usually a good spot, unless it's a super small, like 0.0004. All right, so we come up with 3.3. X is about 3.3. Yes?
Do we have to put the squiggly?
I'm not concerned about it. Technically, you should anytime you don't know for sure. All right, the next problem. I'm going to add something to it. It says find length of C. We're also going to find angle B or cap B. We're also going to find that angle, just to add a little twist to it because it's more fun that way. Because finding C is going to be almost the exact same one as we had. All right, so let's label the information we know. We know side A. So Logan, see how the A, B, and C are completely different orders?
Yeah.
Doesn't matter. Doesn't affect anything. Just make sure you label things correctly where they're supposed to go. So side A is opposite angle A, so that's 10 feet. Angle C is 60 degrees. Side B, which is opposite B, is 14 feet. Guess what? That is side angle side. So we are going to use the law of cosines. And that is going to be side opposite there. Trying to find side C, so we'll have C squared. Is going to equal 10 squared plus 14 squared minus 2 times 10 times 14 times the cosine of 60 degrees. I'm going to give you a second to solve it, and then I'll write down what I got. You got it wrong?
Oh, I forgot to-
Yes. That's a pretty important part of it.
Yours did not, really.
Let me see. Oh, I bet I know what you did.
You got a syntax error? You should get about 12.5 feet. If you're someone that's notorious for making calculator errors, do this bit by bit. Just do all of this, round it, and then take the square root of your rounded answer. Don't try to plug all of it in if you're notorious for just making those little tiny mistakes, parenthesis-wise or other. You can work bit by bit. Things can be decimals off from mine. What was that? I got 12.5.
Just do it.
So if you're making mistakes on it, try it again later, and then ask me questions. I need to move on, because we need to find angle B. Well, to find angle B, we can actually either use law of cosines, because now I know all three sides, or we can use the law of sines. Each one is about as hard as the other. I'm going to go ahead and use law of sines. All right, I'm going to go ahead and use law of sines. So law of sines is going to tell me, find the angle that I know, and I need to also know the side across from it. So that's going to be angle C is 60 degrees. The side across from it is 12.5. So that's the one we're going to use. And we're trying to find an angle. So I might set it up like this. I might say, well, I'm going to put the angle on top because that's what I'm looking for. Cosine of B over side B is going to equal cosine of C over side C.
Wait, why aren't you doing sine?
Oh, yeah, sine.
Dang it,
I was in the middle of either doing law of sines and law of cosines. I decided to mix them both together into one awesome sine. Okay, so it's sine B over B equals sine C over C. Well, that's going to give me sine. Well, I don't know angle B yet, so we can't fill that in. But I do know that side B is going to be 14 feet. And that's going to equal sine of angle C. Angle C is 60 degrees. Over side C, which is going to be 12.5. And we start simplifying. We'll get sine of B equals 14 times sine of 60 degrees, all over 12.5. But that won't actually get me B. I need to take the sine inverse of both sides. So in fact, I'm going to shift this over just a little bit so I can fit a little sine inverse in there. So shift that over just a little bit. We're going to take the sine inverse of both sides, because then my sine inverse and sine cancel each other out, and we're just left with sine inverse on the other side. So we're going to come up with B equals the sine inverse of all of this stuff. And you might find it easier just to plug this in your calculator first. round it to the nearest decimal, and then take the sine inverse of it. Either way you do it, you should come up with an answer. And who knows what answer you should get. What do you get?
I got 75.9 degrees.
Anyone agree with that? Okay, yeah, that's 100% right. It's about 75.9 degrees. And we're done, and we're moving on to the next problem. Okay, the next problem is a triangular field. And they give us 3 different sides. They give us 3 different sides. They don't tell us which side is which based upon that triangle, so we can actually pick whatever side we want to. I'm going to pick specific ones, so it stays the same across all 3 classes, or 4 classes, I should say. So I actually picked the line CA to be my 574. I picked BA to be my 572. And finally, I picked my CB to be my 452. Well, these are the easiest to spot because there's no angles. I don't have to worry about where my angle is because it just has to be side, side, side. This is, in fact, side, side, side. So it is law of cosines. It's just going to be our side, side, side version of it. So what I'm going to do is I'm just going to create kind of a wall between here because I'm doing my work to my right-hand side. I'm going to find my angle A first. Let's go ahead and find angle A first. So we're going to start with cosine. Let's write it a little bit smaller. We're going to start with cosine of A is going to equal, so first I'm going to realize that the side opposite A is 452. We only use 452 once in this formula. It is the kind of the weird odd duck out. So 452 is across from it. So we're going to take the other 2 sides and square them. So we're going to have 572 squared plus the 574 squared. And now we're going to subtract away that one that's opposite angle A. So that's our 452 squared. And we put that all over 2 times 572 times 574. So the sides not opposite. So those are used twice, the 572 and 574. The 452, because it across from angle A, is the one that gets used once in our subtraction. Working our way down, we should come up with cosine. I went ahead and I put that on my calculator. I didn't do it all at once. I came up with this was about cosine A equaled about 0.69. To get A alone, we need to take the cosine inverse of both sides. Remember, we're not multiplying by cosine inverse, we're actually taking the cosine inverse of both sides. To get our cosines to cancel out, we're left with A equals the cosine inverse of 0.69, which turns out to be A is about 46.4 degrees. Depending on where you rounded and how you did it. Alright, to find cosine B, you can either use the law of sines or the law of cosines, because now you have an angle. I went ahead and I used the law of cosines, but you can use whichever. I want you to go ahead and find angle B. I want you to go ahead and find angle B, which will get you angle C. And I'll put up the values right now of what you should get. So A is 46.4. We did that together. B is what you should be finding. You should get about 67.1 degrees. And C should be about 66.5 degrees.
Do we do the law of sines?
Like I said, you can use whichever one you want. We need to talk about these last 2 formulas. These two formulas would have been very useful on the homework last night. Because area of an oblique triangle is equal to 1/2 side A times side B times sine of angle C. So all it's saying is, if you have angle C and the two sides flanking it, you can just plug it right in and you get your area without having to worry about 1/2 height and base. You can just plug this in. However, in order to use this formula, you still have to have angle side, side angle side. You need to have side angle side to be able to use that formula. So on that number 25 of the homework, it was missing one of our angles. We would have had to find it either way. So you need to find sine angle side in order to use this formula to find area. Once again, formulas can go on that formula sheet. The other one is pretty cool. It's Heron's area formula. We're not going to go through the proof of why this is true. It's actually, it'd probably take most of these two boards for me to prove it. We're just going to take it that it is true. However, if you look at this, you first find S. S is equal to all three of your sides added together divided by 2. And then you take whatever value you have and stick it for every place that there's an S, and you have to put your sides in. So in order to do this one, you have to know all three sides. So whenever I tell you to find area of a triangle, you should ask yourself, do I have side angle side? Or do I have side, side, side? If you do not have either one of those, you have to make it happen. All right? So if you have like angle side, side, you need to find that angle that's between the two sides in order to use this formula. All right, any questions on that? Okay, let's go ahead and start our homework. I'm going to do the law of sines on this one to see what is wrong with the other people. So I'll go ahead and write that up here.